Hello and welcome to this session on the top 30 most important Java interview questions and answers by Intellipaat. While preparing for your placements in third year, selecting between C++ and Java becomes a little difficult. On one side, you have C++ with its speed and performance, and on the other, you have Java with its ease of use and automatic garbage and memory management. I don't know about C++, but while choosing Java, in case if you're thinking that after almost 30 years, Java might be slowing down, let me tell you something, you are very far from the truth. Be it the TIOB index for the top 10 most popular programming languages or GitHub's yearly state of the Octoverse, Java always had a spot reserved in the top 3 since its launch back in the 1995. And even when other popular programming languages like Python, C++, and JavaScript were going through periods of rapid growth and decline, Java continued to maintain a slow yet steady and upward trajectory. And it's not just about the growth. Java also tops the charts when it comes to both job openings with over 16,000 vacancies and salaries with an estimated average salary of 6 lakhs per year for a fresher. Now, if you're willing enough to pursue Java, then we can proceed with this video. Today, we will be covering a total of 30 questions which will be split into 3 main categories: easy, medium and hard, with 10 questions in each section. So without any further ado, let's dive right in. If you choose Java, there is no escaping the first and the slightly confusing question. What do you understand by JDK, JRE and JVM? So these three, JDK, JRE and JVM, are all closely related and interconnected within the Java ecosystem, with JDK being on top, followed by JRE and JVM. Since JDK is at the top, let's start with it. JDK or Java Development Kit is the software development kit that provides all the tools required to develop, compile and run Java applications. JDK is further split into 3 parts: compiler, debugger and JRE. The compiler translates human-readable code into machine-readable bytecode. The debugger helps identify and fix the errors in your code, like warning you about the missing semicolon in this code. The JRE or the Java Runtime Environment provides a bunch of core libraries and components. Keep in mind that unlike JDK, JRE does not provide these libraries for development. It can only be used to run the Java applications. Along with the core libraries, JRE also contains JVM. JVM or the Java Virtual Machine is an abstract machine which is responsible for interpreting the bytecode from earlier, enabling Java's trademark write once, run anywhere or the platform independent capability. Key components inside JVM include memory management and garbage collection. Memory management allocates and deallocates memory for the application, while garbage collection automatically cleans up unused memory. So in a nutshell, JDK is for developers to create Java applications, JRE is for users to run Java applications, and JVM is the core engine that executes bytecode, which makes Java a platform-independent language. Moving on to the next question, what is the Java main method? Now, a Java code cannot be started without the main method. It acts as a starting point while executing any Java application. That is, when you execute your Java program, the JVM, our abstract machine, looks for the main method to begin the execution process. Keep in mind that every Java application must have a main method and only one main method in its starting class. This one particular line that you can see on the screen, which includes the main method, is so important in Java that 6 different questions can be generated from it. And that is precisely what we will be doing. Which brings us to our third question, which is, what is the significance of the string args? The string args parameter in the main method is used to pass command line arguments into your Java applications. That is, extracting values from the command line in string format. These extracted values are stored in the args array, which can later be extracted as args0, args1 and so on. Now, if you need to perform any arithmetic operations using these values, you first need to convert them into integer format, namely num1 and num2, which in this case we will be using for addition. Done with the string args and moving on to the next question. What is the significance of the static keyword? The static keyword has a huge impact on how elements stored within a class can be accessed. Static can be split into static variables and static methods. To understand this better, think of it like a housing society. Now, Static variables are like the public swimming pool and the common garden or park, which can be accessed by everyone in the housing society. Static methods are like the shared services, like the security guard or the maintenance crew, which again, anybody can access whenever they want. Non-static members, on the other hand, are like the individual features within each house. This can also be split into non-static variables and non-static methods. Non-static variables are like the furniture or the number of rooms within a specific house. And non-static methods can be like the actions performed within a specific house, like turning on the lights or cooking in the kitchen. Take a good look at this code for a better understanding. Now, because the class car is non-static, to access the variables defined inside the car class, we need to create objects, namely car1 and car2. However, in the case of static variables and methods, we don't need to do any of this because they're accessible globally within the scope of the class. Like in the case of this counter class, where you can access the value of count without creating any objects. So in a nutshell, adding the static in here is to declare a method or a variable as global. Also keep in mind that static variables and methods can only be accessed by other static variables and methods. We've talked a lot about methods, but what exactly is a method? Which prompts us to our next question. What is a method in Java? A method is a block of code that performs a specific task and can be reused multiple times throughout the program. Methods in Java is similar to functions in C++ and Python. It can receive inputs, process them, and return an output. Or it can simply perform an action without returning anything. The reason behind using methods is to avoid code duplication, making the code more modular and readable. That's all you need to know about methods. Moving on to our next question, or the sixth question, which is, what is the difference between subclass and superclass? A superclass and a subclass have a parent-child relationship, which is created due to the inheritance like we saw in the previous question. The base class from which other classes are derived is called as the superclass or the parent class. And a class that inherits from the superclass is known as the subclass or the child class. If you look at this code, class animal is the superclass containing the method eat. If a new class called dog is created and which inherits the class animal, it will be known as the subclass or the child class. So in a nutshell, a superclass acts as a parent providing common properties and methods, whereas a subclass inherits the properties and methods from the parent class, but they can also add their own unique features as well, like the method bark in this case. Now that you know about parent and child classes, it's time to see them in action with our next question. What is an abstract class in Java? When you want to make sure that the properties or behaviors used in the parent class must be implemented in the child classes as well, then you use an abstract class. The interesting part here is that some methods in the abstract class can be declared without a body, which must be defined by the subclasses, like your parents asking you to pursue their unfulfilled dream of becoming a doctor, or in this case, an abstract class called shape. In the code, you can see that the abstract class shape has two methods, an abstract method draw and a non-abstract method or a concrete method erase. Now, if a subclass or a child class were to inherit this, then the abstract method draw must be included, else it will throw an error. But as for the non-static erase method, implementing that is totally up to you. So in a nutshell, an abstract class provides blueprint for the subclasses, defining the common methods and properties. An abstract class contains abstract methods which must be implemented by subclasses. Moving on to our next question, what is an interface? Now, an interface and an abstract class are very closely related, except you have the choice of choosing between abstract and non-abstract methods inside an abstract class. But when it comes to interface, every method is by default abstract, meaning every single method declared inside an interface must be defined inside the subclasses as well, else it will throw an error. Yet, the reason why interfaces are still used is due to their ability to perform multiple inheritance. That is, say I have this parent class called bird, and I create two more classes called flyable and swimmable. Now, I'm creating a new child class called as duck, which will extend the bird class. Now, ducks can both swim and fly. Hence, when I'm creating the class duck, I want to inherit both the flyable and the swimmable classes. However, in Java, this is not possible. And that is where interfaces come into play. If I change flyable and swimmable into interfaces, then I will be able to implement it within my classes. Now, because these are interfaces, naturally I have to incorporate the sound, fly and swim method inside these interfaces, else it will throw an error. So, in a nutshell, interfaces are used to solve the problem of multiple inheritance in Java. Moving on to our next question. What is a package in Java? That is a built-in package and user-defined. A package in Java is a way to organize related classes and interfaces into a single group. It's similar to folders in your computer, where related files are kept together. There are two types of packages in Java, built-in packages and user-defined packages. Built-in packages are the ones that are provided by the JDK. These offer predefined classes and interfaces like the java.lang, java.util or the java.io. User-defined packages, on the other hand, are the ones that are created by developers to organize their code and keep their projects structured and manageable, like this code. And the structure of your file should look something like this. My package is the name of the folder that I created, inside of which I have the inside package.java file. Now let's move on to our last and one of the most important questions of this module. That is, what is the use of this keyword in Java? So in Java, this keyword is used to refer to the current instance of the class. For example, in this class called person, if you have to refer to the name declared within the class, then you need to use this keyword to do so. Without using this keyword, you will be referring to the parameter passed into the constructor. Apart from this, this keyword can also be used to call another constructor within the same class and can also be used to return the current instance to enable method chaining, or it can even be used to access an outer class from an inner class. And with that, we reach the end of this module. Now moving on to the next module. Alright, now let's start with our medium module and let's look at our 11th question, that is, how do you read and write files using the java.nio.file in Java? Now java.nio.file is an import statement, and using that, we're supposed to show how to read and write files. So let's look at the code. Let me open my VS Code over here. 11th question. Before I proceed further, let's import the java.nio.star. We'll need the file. Yeah. So for reading or writing into a file, we need to create a file. So let's just call it, I'll call it a.txt. Hey, this is a file. Okay. Now path is a class that exists inside the java.nio.file library. So we're going to use that to read the content inside the file, that is a.txt, and write contents into the file a.txt. So let me create a variable paths.get. We're gonna put in our file here, which is a.txt. Make sure that it's in the same location. Right here, my a and a.txt and the main Java file is in the same particular folder. That's why I'm accessing it like this. Then we need a try and catch statement. Let me create this string content, another variable. So inside of this content variable, whatever the content I'm going to read from the a.txt file, I'm going to store that inside this content variable. So let's do that. File.readString of this path p1, and we're going to print it out. I'm going to print out the content. Now if that doesn't work, we're going to throw an exception, which will be your, let me just write, something went wrong. Now let's try to run this file. And there it is. Hey, this is a file. So that is how you read from a file. Now let's write into a file. Now for this, we need another try and catch statement. This time, instead of reading, because when we were reading, we need to store all of that data in particular variable. That is why we created the content variable. But this time we're writing into it, so we don't need to store the data anywhere. So we're going to use write string this time, which will be our path and the file name and whatever content we're going to write. For that, I need to create a variable, string value. So let me just write hello world. This, if you want to, you can just directly write this here as well. But to make the code a bit more cleaner, I'm just going to write value. And after this is done, file written successfully. Okay. Obviously, we need a catch statement. Oh, I didn't copy the C. Okay. Now let's try to do that. Okay. And it's hello world. So if I try to run it again, this should also get changed. Okay. That did get changed. It became hello world. Okay. That's it with this question. Let's go back to our PPT. And we have our 12th question. What are access modifiers and what are the types of access modifiers in Java? So in Java, we primarily have 4 types of access modifiers. That is the public, private, protected, and default. Now, public is used when a class, method, or a variable is to be accessed globally. That is, any class from anywhere in Java can access this particular class, method, or variable, any other Java file. Then it is called as public. You make it private. If you declare a method or a variable as private, then it can only be accessed within the class in which it has been declared. Protected is when you want to make sure that when a child class inherits from a parent class, only then the particular variable is used. The element is only accessible within the same package by the subclasses. That is, only the child classes are able to access the protected variables or methods from the parent class. Then default is when you don't declare anything, any access modifier to a variable or a method or a class. It is by default called as default. Okay, so let's look at the code for this. I'll have to create a new file. All right. Let me just declare a public variable here. Public variable, which is going to be called as 1. Then I'm going to declare a private variable. Then I'm just going to declare a default variable. Notice how in declare I'm not writing anything. It's just there is no access modifier as public or private, so it's by default. Now, as for protected, I'll have to create another class here, say class animal, and protected string name. And I'll need a constructor here. And this protected method will display the name. Now, this is my parent class, class animal. Let me just create a child class that is not dog. And I'll need a constructor here as well. Supername, we'll be inheriting it from the animal class. All right. Now, if I were to create a dog class, say, what do I name my dog? Lucy. Okay. Now, if I try to access display name, keep in mind that display name is a protected method inside the parent class. So if I try to run this, the name is getting printed, Lucy. So that's what I said, a protected variable can only be accessed by a child class. Now, as for these three, let's create another file, 12, extend it. I'm just going to call it num. Yeah. Now, if I try to access the public var, the private var, and the default var in this particular code, we'll have 1, 2, 3, right? But now, if I try to do the same thing outside in any other file, it's already declaring the field Q12 is not visible. You cannot access this. So even if I were to run this particular code, it will definitely throw an error. Private var has a private access and it cannot be accessed outside of the class. But if I were to comment it out and try to access the rest two, 1 and 3. Okay. So moving back to my PPT. But now when to use which constructor? That is, the public should be used when the classes or the variables need a broader access, like a utility class or a helper class. Private should be used when you need to ensure that variables cannot be altered or accessed by other parts of your program or any other class outside of your main class. And protected should be used when you want to give access to subclasses even if they are in different packages, but prevent access from a non-subclass. That is, if any class which is not related to the parent class tries to access that particular variable, then it should not give access. Then default is, well, it's default. When you want to limit access to classes within the same package but keep members hidden from classes in other packages, you can use default. Okay. Moving on to our next question. Explain the concept of constructor in Java. Now, constructor, we have already declared a constructor in the previous question, but constructor is one of the most important concepts in Java. Let me tell you why. So, let me open my VS Code over here again. Alright. We already had a class. This time I'm going to call a class called as book. Now my class book contains string, title, its author, and the price, which I should be taking in double, but I'm going to take in int to make things easier. Now let's just try to do this first without using a constructor. Sorry, I'm lazy. All right. All right. Now, I try to create a new book, say B1 is equals to new book. Say the title is Verity, author is Colin Hoover. God, I don't know the price. Okay, I'll just put 200. I'm not sure. Colin Hoover fans don't hate me. So now if I were to access the one of my favorite books is the title by the B1's author. If I try to run this code, right now everything is normal and fine. Whatever I've declared, that is, I can see that here. But what happens when I try to declare a book without specifying anything, that is, without specifying the title, author, or price? Now you can see an error is being thrown by VS Code. What is this error? The constructor book is undefined. This is where constructor comes in. If a value is generated, if an object is generated which does not contain any values, that is when constructors come the most in handy. That is, if I were to create a constructor here, public book. So by default, the title of my book would be, I'll just put title. I'm still lazy. Author is author. By default, my book is 200. Now you can see that the error is gone. So if I were to print out the same line here, instead of B1, let me quickly stuff B2. So now if I run this, my code will work, and the default value that was initialized by the constructor, that is title and author, will be displayed for book 2. So getting back to my PPT, a constructor in Java is used when you want to initialize the values that are declared in a class. Let's look at the technical definitions. The primary purpose of a constructor is to initialize the object's properties when the object is created, like we just saw for title and author. A constructor doesn't have a return type, not even void. And a constructor is always named as the class's name, the book, and it never has a return type because it's just there for initialization, not returning any values. And there are two types of constructors, that is the default constructor and the parameterized constructor. Even this that we just used, this is a constructor. This is a parameterized constructor, that's because we're taking parameters here, we're taking arguments here. And here we don't have any arguments, that is why this is called as the default constructor. So let's move on to the next question. That is, how is method overloading different from method overriding? The key to understand, I know method overloading and method overriding is always confusing, but the key to the answers is hidden in the question itself, method overloading and method overriding. When I explain this, it will get clearer to you. So that is our question 14. Let me create a main class. As for method overloading, let's do method overloading first. And how that works is, say, if I have a function called as addition, which takes integer a and integer b, and this is of int type because it returns a plus b. And if I create the function again, but instead of integer, it's returning double this time. And the parameters used are also double. Now both these functions, the addition with the integer and the addition which returns double, both of them have the same name, addition, but they are both returning different data types. That is called as method overloading. Now as for method overriding, say if I have a class here, a method, animals make different sounds. Don't need a parameter here. Now inside class dog, I'm gonna call on to the same method, which is sound, and I'm gonna put dog, it's a sound here. So now in the main class, if I create a dog object, and if I call on my sound method, you would see the woof woof, which is coming from the dog class and not from the animal class. So that is called as method overriding. That is removing or overriding an already existing method. Now going back to my PPT, let's look at it in a much more technical terms. Method overloading is same method name, different parameters, and and when to determine that if a method, which method is being called, that is determined at the compile time, like we did in the case of addition, the int addition and the double addition. Method overriding is the same method name and parameters, but different implementation, like the method sound. Both of the methods sound in the animal class and the dog class were not accepting any parameters, but the implementation was very different for both of them. Different implementation, subclasses, runtime determination. Moving on to our next question. Explain the difference between final and finally keyword. As for final, it is divided into three. Final variables, which are once assigned, their values cannot be changed. Final methods, which cannot be overridden by subclasses. And then final classes, which cannot be subclassed. Let's look at all three of them. Let me open my code. Question 15. Okay. So first we have the public variable. So if I were to create a final variable, let's say final int 10, and if I call out this value, it will work. However, if I try to modify this and then run the code, cannot assign a value to a final variable. That is, once assigned, it cannot be changed. Final variable. Now let's look at final methods. So final method, for again, I need my class animal, right? No, I need it from here. I'll take it from here. All right. Now, if I declare this as final, it immediately throws an error, the dog class, that cannot override the final method from animal. Final methods cannot be overridden. So if you want to make sure that once your method is declared, if the subclass, if you want to make sure that your method should not be overridden by subclasses, all you need to do is add a final keyword. Similarly, for class animal also, if I simply add a final, another error is thrown. The type dog cannot subclass the final class animal. That is what a final keyword is. I don't want to keep the error here, so I'm just going to remove it. And as for your finally, I'll just show you how that works. Say we have a try and catch block here, and I'm trying to divide this by 0. Now obviously this is going to throw an arithmetic error. So if I try to print out sum, it will definitely not work. It would it would throw an exception, which would be the arithmetic exception. So let me try to run this. Wait, I'll just add the finally block here. This will be executed regardless. Now the finally block is used so that the finally block of code will be executed regardless of whatever happens in the try and catch block. Let's run it and see, shall we? Divide by 0 exception. This will be executed regardless. So right now it's getting executed because the try and catch block did work, right? Even if I remove this and then I try to run it, this will be executed regardless. That is the finally keyword. It will be executed regardless. So although final and finally sounds the same, they are not. So let's look at the PPT. Finally ensures that certain codes run after try catch regardless of the exceptions. Moving on to our next question. What are Java collections and why are they important? Now there are different kinds of collections in Java. That is, we have the list, the set, map and queue. Let's look at them one by one in the code so that you can get a better idea of what exactly a collection is. Let me open my VS Code again. Java. Main class. Alright. Now as for list, I'll need to import the class first. Alright, so let's create our list first. I'll create a list of integer it's integer. All right. We're going to call it students new array list. Now we'll need to add some values into this. All right. Now you can see that all of these values are duplicates. The two of them are duplicates. Now if I try to print this integer x in students, let's try to run that, and everything is printed. That is because list is a type of collection. Collection is any long list, you can say, of memory in which you can store a lot of values. So list basically allows duplicate values. Next, we have hash set. I'll comment it out. Now, this is the problem with lists, that it allows duplicate values. That is where we need hash sets, because hash sets is like sets, and if you have worked with sets before, you will know that sets do not allow duplicate values. So if I do the same thing here and then I print this code, only 100 and 101 is printed because those are the only unique values in the list. Next, we have hash map or map. Now, these are used when you want to store a key value pair. Let me show you how that works. Next, we're looking at hash map. All right. So, two values are required: a key and a value of that key. Students new hash map. Students.put VS Code is so caring of lazy people. Let me just put a name first, Alice. Now you can see that all these values, the keys are not unique. They are the same. And as for the values, they are also the same. Now let's try to print out the values. For map.entry, we have string first, followed by integer, entry, students.entry set, and entry.get key, alright. So now if I try to run this code, you will see I'm only getting one value, because it doesn't really care about the value, even though it should have returned Alice 101 and Alice 101, because there are two different entries for Alice. But it only looks at the key. The key should be unique. So if I put other names here, B, C, D, now although the values are duplicated, it will not care. It will simply return B, C, D and Alice with the duplicated values. So the values can be duplicated, but the key should be unique, or else it will be just one single value. Moving on, we have linked list. Let me just comment that out. And we have linked list or queue. This is going to be so similar like these. It is a linked list. All right. I need to take this one because it's string. We can't use put in linked list. It should be add. All right. Now, let's print out the value. Current Now there are two methods in linked list, that is poll and peek. Peek will reveal the top value, poll will just pull out that value. So this will be next, not current. So let's look at poll first. Poll will just pull the value out, which will be, I believe, Alice. And next is B. Alright. So now let's look at the official definitions. List is a collection that allows duplicate elements, as we saw. Set doesn't allow duplicate elements. Map stores keys to values, with each key being unique. Value can be unique or cannot be unique, it doesn't really matter. Queue is an ordered collection that follows the first in, first out or priority based ordering. Let's move on to the next question. Describe checked and unchecked Describe checked and unchecked exceptions. Again, we need code for this, but what are exceptions to begin with? Exceptions in Java are the issues that arise during program execution which disrupts the normal flow of the application. Like we looked at the case of the arithmetic exception that was happening when we tried to divide our 10 by 0 in one of our previous questions. So I knew when I was trying to explain the finally block code that this will throw an error. But sometimes when you're executing a code, you don't know when it is going to throw an error. And such a case is called as an exception, when something unplanned happens. Now there are two types of exceptions, checked and unchecked. Checked exceptions are the ones that must be handled or declared at compile time, as they represent predictable issues. Most of the times, checked expressions are the ones that will throw an error, and that's why they throw the error. Next, we have unchecked exceptions. Occurs at runtime, doesn't request explicit handling, often arises from logical errors or unexpected conditions. Now, this is mostly, not unchecked is not completely this, but mostly unchecked exceptions happen because of some logical errors that you create, that happens from your side. So because of that, they don't necessarily need to be handled. Now, let's look at both of them with the help of an example. This is question 17. As for checked, say if we were using this same code, and I am trying to not write into the file, I'm trying to read from the file, and I'm trying to access a file called as b.txt. Now the thing is, b.txt doesn't exist. I haven't created b.txt. So if I try to run this, it will give me the error, something went wrong. Or if I just write the exact error, no such file exception. So these are already existing errors. No such file exception exists within the Java.sys library. So that error is being thrown. But now instead of this, this is a checked exception. Now if I were to create, say this, class animal, not this one. Where did we create? Yeah, class book. Now, if I try to run this code and I accidentally, when I was writing the constructor name, I accidentally wrote the spelling wrong. Instead of book, I wrote buku. So now if I try to access this file here, this same thing, if I try to access it, it will show that the constructor book is undefined. Now, obviously, I have declared my constructor here, or I believe I have, but because of my spelling error, it is not technically declared. So this becomes an unchecked exception, where it is not officially declared in the Java.sys library, but it is there. Now, in this category, you can include arithmetic exceptions as well. The one that we looked in the try and catch block where we were trying to divide it by 0. That is also an unchecked exception. Now, let's move on to the next question. That is, anyways, we were talking about exceptions a lot. So how do you create a custom exception in Java? This is actually very interesting because you get to throw an exception. You can throw an exception based on any condition that you want. So let's do that exactly. I need my file, main file. Alright, so in this particular code, let me just walk you through what I'm going to do. So my custom exception is going to be about an invalid age, so that if any particular age, which is, say I am hosting a party at my house, so only a certain age group of people can come to my house. So that's why I'm throwing, and if anybody is below the age of 15, they are not invited to my party. They are not allowed to my party. So for that, I'm creating an exception. That is an invalid age exception. So let's try to do that. Class invalid. Oh my god, invalid age exception. Obviously I need a constructor. This is a parameterized constructor which would show a message. For that, it needs to extend exception. Now let me just create a method here which will check the ages, and now this throws my invalid age exception error. If the age is less than 15 or the age is more than 30, then you need to throw the invalid age exception with the age is not allowed. Sorry. Okay. Else is always welcome. Now let's try to run the method here. So we're going to call the method with the age, let's say 10, and we're going to catch it with the invalid age exception E, and we're going to print that. Let's try to run this, and 10 is not allowed, sorry. Let me add another try and catch block with the age of, say, 20. Now if I try to run this, 20 is always welcome, 10 is not allowed, sorry. So that's how you create your own custom exceptions with Java. Returning back to our PPT and moving on to the next question, that is, explain the use of try, catch and finally blocks. We already saw try, catch and finally blocks. We looked at it so many times. So inside the try block, you put a code that might throw an error. Try and catch block is always like playing it safe. It's like when you're riding a bicycle, you wear the gears so that in case you fall, you are safe. So that's how the try and catch block works. So try block is when you know or when you feel like the code might throw an error, you put it inside the try block. Catch block is for catching the error, whatever exception happened, and handling it. That is what catch block is there for. Finally, like we already discussed before, finally executes regardless of whatever is happening inside the try catch block. It doesn't care. It executes anyways. Moving on to the next question. Describe the difference between equals to and the dot equals in Java. This is an interesting question now. Alright, let me just open my VS Code over here. Question 20.java. The main method. The interesting part here is that the equals to operator is used to show the equality between two variables. Say if I have a string called as hello, and if I make another string called as b, and then if I try to compare, you can see the contents are the same, but if I try to check is a equals to b, I will get false. Even though the contents are the same, in the backend, both a and b point to different memory locations. So technically they are not the same. However, if instead of string, if it was a number, and then if I try to see are they the same, then they are the same. So in case of numbers and other primitive data types, equal to operator turns out to be same. Now how do I check if both these strings are equal, because this doesn't work, right? So that is where you use the equals. Oh, it's string. All right. Now if I try to run this will give me true. Let me go back to my PPT and we'll look at this in a more technical terms. So the equality operator, or the double equal to, is checks if the two reference variables are pointing to the same memory location. And in case of primitive data types, they are, but in case of strings, both are pointing towards different data types. As for equals, it checks if both objects have the same data, and that is specifically for strings. Now with this question, our medium module is completed. Let's move to the hard part, that is, describe the Java memory model and how memory is allocated. Alright, so one thing you need to keep in mind while working with the Java memory model is that in Java, memory is allocated in two types. The first one is heap. Now heap, as you can see with this particular vector, is a large memory space which is used for storing objects, instance variables and class variables. So think of it like a library, a huge library, where in the archives section you have a bunch of books stored. So that is like heap, which is like a storehouse for all the memory and all the variables and all the methods. Everything is stored in heap. So objects that are no longer reachable are removed and managed by JVM's garbage collector. So I've mentioned this before as well, that Java has an automatic memory management and automatic garbage collection. Whatever variables or methods or classes are not actively in use are removed by JVM. They might have a specific threshold in order to remove them, but that is removed automatically by JVM, meaning you don't have to worry about it. Next, you have stack. Now, considering our, expanding our earlier library example, think of stack as the particular table of a librarian. That is, each thread in Java has its own memory, own stack memory. Whenever a thread is working in Java, it gets its own table and chair. That is its own stack memory. Now, stack memory is generally limited and temporary, unlike heap. Now, how is memory allocated is a whole process, which starts from creating the object or object creation. The JVM first determines the size of the object based on its field. So say if I create a particular object, like we created the book object. So now based on the values I'm putting inside the book object, size of the object is determined. Now based on that size, from the heap, a particular section of memory is allocated to the object. That is, if my new object, that is this, is created, then from the heap, consider this as this bookcase as the heap, then depending on the size of this object, that much memory is allocated from the heap to the object. Next, you have to initialize the object. The object's fields are initialized to their default values, which we define with the help of constructors. Then reference assignment. A reference to the newly created object is assigned to a variable. Whatever, like the book B1 is the one that was storing the variables and everything inside that particular object. So that becomes our reference variable. And finally, after everything is done, if that particular book1 variable, I am not accessing it a lot, if that object is not accessed, then because Java has an automatic garbage collection, it will eventually be deleted from my heap forever. The garbage collector periodically scans the heap for objects that are no longer reachable by any active threads. Moving on to the next question, how does garbage collection work in Java? So we talked about how it is automatic, but what is automatic? What is actually happening behind the scenes? So automatic means that it frees up memory by removing objects that are no longer in use or is being accessible by the program. That's the most simple way to figure it out, right? If a particular object is not being used for a long time based on certain thresholds or based on certain rules, then it can be removed. That's how the garbage collection mostly works in Java. But there are other methods as well. The first one is the most obvious one. The obvious one, automatic memory management, where the garbage collector, which operates inside the JVM, manages garbage collection on its own. Next, we have the heap memory, where as long as an object is referenced by other objects or variables, it remains active. And the moment it becomes inactive, it's removed. Then there is this mark and sweep process. Mark marks the object as in use, which means that it should not be deleted. And the unmarked objects are eventually deleted. If a particular object is being used over and over again, then it will be marked as in use. And for the objects which are not marked as in mark, as in use will be removed. Next, there is generational garbage collection. That is the young generation and the old generation. So for young generation, it is usually used for storing newly created objects. And the old generation is the objects that survive several rounds of minor GC and are moved here. So the thing is, in younger generation, the object doesn't stay for long. If it's a temporary object, it is immediately deleted. But if the object is kept on repeating over and over and over again, then it is transferred to older generation. Moving on. And there are garbage collection algorithms as well, because Java is extremely smart. So then there is serial GC, parallel GC, G1 GC, and ZGC. Moving on to our next question. What is a lambda expression and how is it used in Java? Lambda expression or arrow functions are simply used to just make our lives so much more easier. In a very concise way, if you have to explain what is a lambda expression, it's a concise way to represent an anonymous function. This is your parameter, this is your expression, and this is an example. Now let me just show you how much easier this is when you implement this as well. Let's take a look at the code. Question 23. For this particular question, we will be creating threads because I feel like threads are the easiest way I can show you how much of a role lambda plays in a coder's daily life. So, I'm just going to put override here. Now, okay. Thread is running. Close this here. And then I need to also start this. Now this is how a thread will be implemented without using the lambda expression. Now let me just show you how much more easier this gets if you use a lambda expression instead. So that's my thread. Let me just add start here. And that's it. This whole line can be simplified into this. That is why we need lambda expression. So let me move on to my PPT and let's move to the next question. That is, explain the importance of, explain the importance of the synchronized keyword. Now, the synchronized keyword in Java ensures that only one thread can access the synchronized section of the code at a time, blocking other threads until the lock is released. Now, this is like if you must have studied operating systems, you must have studied about deadlock. This is exactly like the condition. So there we had semaphores to solve the condition of deadlock, and this is something similar. Synchronized keyword also helps prevent deadlock condition in Java. Now let's see this in action so that you can have a better understanding. So I'm going to open my VS Code over here. Let me create a new class. All right. I'm going to create a class counter. And I'm going to specify a value, a variable called as count in this, and then I'm going to show you. Now the variable count that is going to be specified inside this counter class is a global variable, meaning anybody can access it. Any variable in this particular class can access it and modify its value. But that is not what we want, because if such a thing happens, then it will be a complete chaos, because any variable will be updating the value of count at any moment. And you might think that your output is supposed to look a certain way, but because some other variable modified it, it can get completely changed. So synchronize basically helps prevent that. Let's see how. So let me just create my variable. I'm going to add a synchronized here. And I'm going to create a function called increment, which basically increments the value of count. I'm not going to let the variables access count publicly because it will just create a chaos like I just described. So that's why we just add a function so that that kind of chaos can be avoided to some extent. Then we also need a function to get the results of the count. That is return count to see the specific present value of count. Moving on, let's create an instance of the class. Alright, now let's create 2 threads which are going to access this particular value and try to modify this value. So my first thread T1 it is just going to count. Let me just call this counter instead. That would make a lot more sense. Increment. Alright. Now similarly we need another thread T2 which would do the same thing. Let's start both the threads and then we need to join them. We need to do the same thing for thread T2 as well. Now we need to add the print statement to just see the value of our count. After calling them twice, let's see the value of count. This is increasing counter 100 times. This is increasing counter 100 times. So the value, because we have used the synchronized keyword, should be 200. So now let's just try to run this code. Now based on the 2 increments that we're doing here, it should give us the value of 200. And there we go. We are getting the result as 200. And now that's, if you see this thread and this thread, threads usually work in parallel. So both of them are trying to increase the value of counter at the same time. But because we have used the synchronized keyword, only one thread process is able to access the value of the count and increase the value of the count at one time. Hence, we're getting the answer 200. Else, it could have been a completely different value if both of them were trying to access the value at the same time. So now let's move on to the next question, which is, explain the volatile keyword in Java. Now, volatile, as the name suggests, is exactly how the definition goes. As in, when a variable is marked as volatile, changes made to the variable by one thread are immediately visible to other threads. That means whenever the volatile keyword is used and the value of the particular variable is changed, the data, the variables' data, that stored data, is stored from the main memory and not from the threads' local cache. We've already discussed how Java stores memory in heap and stack. So the data that is stored in heap is called as the main memory. And the memory that is stored in the stack, which is like there so that you can access it rapidly, is temporary. You access the data, you modify it, you put it back. But when you use the volatile keyword, any changes you make to the particular variable, it doesn't just stay in the temporary stack, it is updated permanently in the main memory. So hence volatile means you have to be very careful with that variable. It's very fragile, you have to be very careful. Alright, so let me show you another example so that you can get a better idea. Let me create a new file. I'm going to create another class counter again, but this one's going to be a little different because inside of this we will be creating a boolean value instead of an integer value like we last did. I'm gonna start this off with false, and then obviously I need a function to change the value of the flag. That is going to be toggle flag. So flag will be not flag, this function is called. Alright. And then again we need a function to be able to get the result of whatever we are doing, of the current value of the function. So this is going to return the flag. Again, coming back to the main class, we need to repeat the whole process. Don't mind me. I'm just going to copy it from here, paste it here. There are a few changes we need to do. counter dot, it won't be increment, it will be toggle flag. And obviously I need to add something here so that you will know that the toggling has happened. This is thread 1 flag toggled to get flag. Alright, we're going to make a couple of changes here. We don't need the for loop, for example. And here, we're going to add a condition instead of the for loop. We're going to add a while loop with a condition that while not counter dot get flag. That is, until the flag is true, this loop will keep on running. Now, because we're using the volatile keyword here, as soon as thread T2 now keep in mind that we are not using the synchronized keyword here. So that means T2 can directly go and access this particular flag and check for its value, which is false. So that means it will be continuously stuck in this particular loop. But thread T1, which would run maybe a second before T2, will go there, toggle the flag and change the value to true, which means as soon as T1 changes the value to true, it will be updated in the main memory that T1 has changed the value. So flag's value becomes true. Hence, when T2 tries to access the value of flag, it is true and it will pop out of this loop. Thread 2 flag becomes true, exiting the loop. Now, because of the volatile keyword, thread T1's activities will be immediately updated in the main memory. Hence, when T2 goes there to fetch the value of flag, it is already true. Hence, this loop will directly exit. Now, we need to do the same thing again. I'm going to copy everything again. This we don't need. So, if we run the code, flag becomes true, exiting the loop, and flag toggled to true. As soon as the flag was toggled to true by thread 1, thread 2 was able to access it and exit the loop. So that is what volatile keyword is doing here. If I hadn't used the volatile keyword there, then although Java has a updated memory collection, okay. So that's it for this question. Now let's move on to the next question. That is, what are streams in Java and how are they used? Now, streams in Java is like a pipeline which has like chunks of data, which makes it easier to transform, filter, and collect data from collections. So basically, the main reason why we use streams is because it can achieve parallel processing, which would enable multi-core processors for performance. So if you're trying to just filter out a data at one time, that will be one thread. Then you're trying to map it into something else, that will be another thread. Then you're trying to collect the data, that will be another thread. So instead of this, you can just use streams, which will just bind all of them together. And instead of running them differently, you can run them together, achieving your multi-core processors for performance. Now let's say an example so that you have a better understanding. Question 26. The main class, I need to import java.util.star and then this is a string, my list. I'm just going to create a list which is a string. Let me add values into the list. Okay. Alright, now I'm going to create a new list after this one, which will be a modified names list. And in here, I'm going to take the old list and I'm going to stream it, and then I need to filter it. Filtering as in, let's just take any variable. You can take name or you can take x. X is this particular variable at that moment. So what you need to do is x dot, if only if it starts with an a will it be included in this particular list. Then I want to make sure that whatever word in this particular list starts with a, it is also capitalized. So I'll add a map function. It will be string to uppercase. And then I'm going to collect this and to list. Bring it back to the list. Alright. I guess we don't need that. The star already. No, we need that. Alright. Now let's just list out the values inside my filtered names. Modified names dot for each. We're just gonna print it out. Let's see how it's coming out. So we have one word which starts with A and then we capitalize the rest of it. This is how streams work in Java. So let's move on to the next question, which is, what are Java annotations and how do they work? Now, in Java, the metadata tags added to the code elements like classes, methods, and fields to provide additional information are known as Java annotations. Now, there are 4 types of Java. I mean, I'm pretty sure that you didn't get much from this particular definition, but you will get a better understanding when I show you the types of Java annotations that exists. Now, the first one, override. You must have used override a lot, and even right now in this particular session, we have used override a lot. That is an annotation. Then there is deprecated. Then there is suppress warning, and there is functional interface. Let's look at them one by one. Let me open my code here, and let me show you exactly for what they are used. Alright, so the first one we're going to start with is at override. So say I have a class animal. Now it has a method in it and a body as well. Alright. Now, I'm going to call a class dog, and this extends animals. Now, I'm going to call the override method. Now, obviously, override method is called here so that the whatever we are inheriting from the animal, say, for example, if I am going to call this method make sound by the dog class, and now if I were to create a new instance of that class, and if I put t1 dot make sound, it should print woof woof instead of animals make sound, right? But if I don't declare the method here and then I try to access it, it will just return me animals make sound from this make sound method which exists inside animal, not which exists inside the dog. So override is basically like a precautionary method we're taking. It is, say, if like I just did a spelling mistake in my last code, right? Instead of flag, I wrote falg. So if that kind of thing happens, instead of maybe the S capitalizing, if I do this, so I am throwing an error. So this is an obvious error. So that's why the override, that's when the override method comes to your rescue, because it warns you that the method make sound of type dog must override or implement a super type. So that kind of reminds you that, oh, I did something wrong and this make sound is not this make sound because there is a typo. So you go back and you change it. Now the override method wasn't there, I will not get that error and then I'll never know what went wrong. So it's just a precautionary method there to just make sure that everything runs smoothly. Moving on, we have the next one, which is deprecated. Now, Deprecated is mostly used to make sure that if you have created a particular class and you don't want the subclasses to extend or to inherit that particular method, then you use the keyword deprecated. Let me show you how. Now, if right here, if I put deprecated, then that means when I try to access this element, I'll get a message. Let me run that again. Java uses or overrides a deprecated API. That means your code is using a deprecated API, a deprecated method. So it just gives you a warning that you should not use it. It's deprecated. Next, we have suppress warnings. Now, suppress warnings are when you want to avoid unnecessary warnings. It just irks you, like there's some particular error there, but it's not an error, it's a warning error. So it might not throw a proper error, and it might not stop your code from functioning, but it's just there and it just irritates you. So that's when you use suppress warning. Let me show you how. I'm just going to comment out the whole thing. Say, oh, I need to import the util class for this. All right, now if I try to create an array list without specifying the type of the list that I'm creating, now if I I'm trying to add a value in here. Hello. Now if I try to run this code, it will work. There is no problem with it, right? It is adding, it is working, but it's still showing that error and I don't want it there. So that is when you put your suppress warning. So we can add the suppress warning from here. I believe it will be right here in the quick fix. Yeah, and for this also there will be a suppress warning there, and now that issue is solved. So now if you try to run that code, you will not get this petty warnings. So next we have functional interface. So let me just show you how this works. Say if I'm going to create an interface called greeting. Now I want to make sure that there's just one particular method in this. There is no more than one method in this. Now if you remember, in interfaces you have to create abstract classes. So that means whatever methods I'm declaring inside of this interface must be implemented by all the subclasses. Now because of this very reason, what if I want to make sure that only one single method exists within this interface greeting? That is when your functional interface jumps in. Now this will make sure that I cannot add any more methods into this interface. Now if I try to add another method here, say not hello, it will not let me add that method because of the functional interface. Greeting is not a functional interface. Invalid functional interface, it will throw an error. It will not let me add other methods. It will only make sure that I am adding only one single method inside the interface. So that is where functional interface comes in. Moving on to our next question, which is explain the concept of autoboxing and unboxing. Now, autoboxing is the automatic conversion of primitive types into its corresponding wrapper class, and unboxing is the opposite of it, converting an object of a wrapper class back into its primitive data type. So the wrapper classes, if you must have used this array list and all, you must have come across integer, like proper integer integer, and then there is the int data type. So int is basically the primitive data type, and integer is the wrapper class which encloses int inside of it. So autoboxing and unboxing is converting them into one another. Let me show you how. Say I have an integer number which is 5. First we're performing autoboxing, where the primitive data type integer is converted into its wrapper class, that is this integer, this one. So now I'm going to create another, say num object, which will contain num. Now if you try to get the class of num object, it will be class integer. Although the value of both num and num object are both containing the value 5, but the type of num object.getClass is dot integer. That's because you've converted this primitive integer data type into the wrapper class integer. And now if we were to do this in reverse, that is, if this value was 5 and then I try to create an integer num like this, still the values would be the same, but this particular 5 has been converted into a primitive data type, and that is unboxing. So moving on to the next question. What is the purpose of the transient keyword in serialization? Now, so serialization is a process of converting an object's state into a byte stream, allowing it to be saved to a file sent over a network. So when a particular file is being sent over from one network to the other, it is transferred in the form of serialization. That is, the data is broken down into small pieces and then it flows in a serialized manner. But the problem of this is that once the data has been broken down, you must have heard of tables and all that we can buy on Amazon, which comes as parts and then you have to put it together and then you can build your whole table. That is how serialization also works. When I'm transferring a particular, say this table to one location to another, I have to break it down. This is not exactly a breakable table, but there are tables which you can like break it down, and then when you move it, because the size decreases and then you're comfortable enough to move it along with you, and then when you reach another spot, you can unbox it, you can put it back together. That is basically called as serialization. Now, some data you don't need it to be broken down, because when you break down a data, it's more likely to lose the pieces of that particular table. Say if I'm breaking down this table, there is a higher chance of maybe the table's leg going missing. So sometimes some particular variables, like say the passwords and all, you cannot break it down. You don't need it to be broken down. It should be preserved as it is. So when you're transferring a password from one place to another, you encrypt it. You don't break it down. So then this encrypted data needs to stay together, or else how will you build it back up? So that is where the transient keyword comes in. It makes sure that whatever keyword you're specifying with transient is not broken down. So the transient keyword tells the Java virtual machine or the JVM to ignore a field when serializing an object. Now, if we were to look at an example, let me just show you how transient keyword exactly is used in Java. Say I'm going to create a class user which implements serializable, which means this should be broken down. Now we have a private string username which you can break down, it's fine. And then you have a private string password which should not be broken down, hence you use the transient keyword. We need to create a constructor with string username and string password. Alright, so this is basically the serializable class, and this is how you add the transient keyword in here. So now when this whole package of the class user is transported, it will be broken down because of the serializable class, but the password is going to stay intact because of the transient keyword. But make sure that when you're transferring the password, you need to encrypt it, because if you transfer the password as it is, you might endure the man-in-the-middle attack. So moving on to our next question and our last question of this session, that is, what is the difference between a string and a string builder? Now, a string is basically an immutable object which once created, its value cannot be changed. And string builder basically means that the value can be changed even after the object is created. One of the biggest problems with strings that I can find is, if you try to modify a string, the same object doesn't get modified, it remains the same, but another whole different object is created, which might lead to performance issues and all. But let me show you how strings and string builders look like. I'll need to create a new class for that. Alright, now say this is my string, contains array, And now if I try to create a new string, or say I'm just trying to modify the same string with whatever string it already was. Right. If I do it this way, now this will work. This code will run. If I try to print it out here and here, initially it was array, then it should be arrays here. Although the value is of the name object itself, but these two are different objects. When you try to modify a particular string, a completely new object is created, and that is one of the biggest drawbacks of strings. That's where string builders come into a rescue. I can just create a string builder with the name hello. Now, if I try to modify this, which is not exactly modifying, I'm just appending this. So now because I'm appending the whole string, which is exactly what I was doing here as well, a new object is not created. Instead, the existing object SV is modified. So if I print this out, it will show me hello world, and this is the same object. A new object hasn't been created. Now, you might ask the question when to use string and when to use string builder. So string should be used when you don't need to modify the string often, or when the string's value is fixed and it should not be changed. String builder, on the other hand, is used when you need to perform frequent modifications, because or else it might run into memory issues and performance issues due to the rapidly new objects being created by string. And with that, we come to the end of this particular video. Thank you for sticking so long, and see you in the next video.